All right, folks, appreciate it. Welcome. Today's presentation is our final project presentation. It's myself, Oscar, and Janavi, who are all part of this final project here. I believe it's group one. The name of this slide is Secure Role-Based Access Control for IoT Sensor Data, a simulated approach to enhancing IoT security using virtual sensors and access control mechanisms. Next slide, please. All right. So, what is the actual motivation here? Well, the rapid growth of IoT ecosystems, everything from things like smart thermostats to air quality monitors, have created essentially a massive increase in data flow, often in sensitive or critical areas. And traditionally, when we're working with IoT security, it's focused on securing the physical devices or the network layer. The thing is, that's only half the picture. So what we tested essentially is determining, what happens when multiple users with different levels of authority need to interact with the same system, right? It's important to understand things like access control and ensuring that the appropriate permissions can only access certain parts of the system. So our project was essentially motivated by a simple question. How do we prevent unauthorized users from accessing or modifying IoT data while still making that same data useful to researchers and the public? Next slide. So our objective, understanding this challenge, this is allowing us to create a appropriate objective, right? What we wanted to do was essentially to implement and test a working role-based access control system using an actual IoT platform. In this case, ThingsBoard. So we didn't just do this on paper. This is trying to simulate a real-world environment. What this does is it allows us to enhance things like data security and usability, making sure that the data isn't just protected, but still accessible to the right people in the right ways, depending on their permissions. So what we did was used virtual sensors to simulate environmental data, and ThingsBoard was our core platform to manage devices, visualize data, and enforce some type of access control. Next slide. So why did we decide to choose ThingsBoard? Well, we have three main reasons for why we chose ThingsBoard. The main one is that it's open source. This means that it's accessible and customizable, which is ideal, for a student project like ours. The second reason is that it supports standard IoT protocols like MQTT, COAP, and HTTP, which is what makes it ideal for any kind of sensor communication. And the third reason is that ThingsBoard has built-in features for dashboards, user roles, and access control that allows us to test different configurations quickly. So ThingsBoard is already used in industrial environments and academic research, which is what made it a very ideal sandbox for building something that we think could translate well into the real world. Next slide. So the system architecture that we worked with. Essentially, what we did was we deployed ThingsBoard in a Dockerized environment using Docker Compose, which essentially gave us an isolated, easily reproducible simulation platform. And next, what we did was built virtual environmental sensors using Python. And these simulated real-time telemetry for temperature, things like air quality, humidity, as well as the sensors communicated with ThingsBoard over, as I mentioned, the MQTT protocol, which is lightweight and reliable and very commonly used when we're working with IoT. Lastly, we also created some custom dashboards for each user role. Admins were able to modify items here. And then we also had a guest user as well. The layered architecture essentially allowed us to test real world settings and policies and see just how things like data visibility and control changed across the different user types that we worked with. So now what I'll do is pass it off to Oscar, who's going to discuss a demo and a more hands-on approach towards the project. So go ahead and take it away, Oscar.
Thank you very much. Now let's take a look at how we have structured access within the system using the role-based access control, or RBAC. We have defined three principal user roles to ensure that everyone has the right level of access based on their responsibilities. The first one, we can find the tenant, and this one is the highest level of access. Tenants have full control over the platform, and they include managing devices, creating and modifying dashboards, and adding or removing users. Then we can find the admin. Admins are given view-only access. They can monitor telemetry data and analyze system performance, but they cannot make any changes to the configuration or data, and they have no access to the devices. The customers, this one have the most limited access. They can only view static, non-sensitive data, perfect for demonstrations or casual browsing without compromising security. To implement this structure, we use several RBAC tools. The first one we use is called user groups. This allows us to assign permissions to multiple users at once, streamlining access control. Here we have the different groups, for example, customer users, we have the administrator, the two tenants, that is the admin and the users, the regular user, and they have different accesses according to the group they belong to. Then we found the dashboard scopes. This let us limit which dashboard are visible to which roles, ensuring each user only sees what's relevant to them. Lastly, we find the widget level visibility. And for more granular control, we can use this approach and even manage visibility at the widget level, showing or hiding specific data components depending on the user role. Together, these tools help us maintain a secure and user-friendly system that adapts to different needs. Now I will go ahead and show the demo. We have here different classes for the project. We have the main program in Python. So let's run it here. Once we start running, we can see there's telemetry being sent to the device. So there is a cloud in SimsBoard receiving all this data in real time. And in here, we can do the email and password to enter to the account, or we made it easier. We can just click here in the tenant, the customer, or the admin, and it will auto-complete the credentials. So let's first try the tenant that, as I mentioned before, is the most highest level of access account. So let's log in here. As we can see, we have access to the sensor data. We'll see after that everybody has access to this data, but this has a special access to the dashboard. We can see here, there is a dashboard for CIS 5370 created in this state, and we can also see the details for the devices. So in here, as I mentioned before, the tenant can manage everything and can see also all the parameters of the device. Let's log out here. Now let's continue with the admin. Let's log in. And as we see, so it disappeared the devices. We can only see the dashboards when we face the user dashboards and the sensor data also in real time. We can also change here the different devices ID to see another configuration for under the device too. So lastly, let's try the account with the least credentials, that is customer. So this one, we can see this is meant to be for final users or just a presentation like this one. It only has access to the values of the parameters. So it's only can only see, cannot modify it, and it's in real time too. So this one lost the access to the dashboard. We cannot see it. And we can see here, for example, in the tenant, we can access the dashboard and we double click it. Once we do that, we can see the real-time dashboard data as a air quality index, the temperature at the PM 2.5 and the PM 10. We can see the real time here in a nice dashboard that only has access to the tenant and the administrator roles. Now I will pass to Genavi here.
Yeah, thank you, Oscar. Continuing with results and contributions, to summarize the outcomes of our work, we successfully created a secure IoT environment by simulating a real-world scenario where access control is crucial. We demonstrated how a lightweight, practical use of role-based access control can enhance security without adding complexity. Additionally, we made our configurations available for reuse via our GitHub repository, which is shown on the slide. This promotes collaboration and allows others to build upon our work. Lastly, we have contributed to the learning process by promoting experiential learning and fostering collaborative workflows in IoT security. Next slide, please. Conclusion. So, role-based access control is a powerful tool for enhancing security in IoT systems, even for lightweight deployments like the one we just demonstrated. ThinkSpot proves to be an excellent platform for creating secure, role-aware IoT systems. Looking forward, this project can serve as a template for more advanced applications, including smart cities, education, and industrial IoT systems. Thank you.
Thank you very much. We hope you liked the project, and we are excited to see your feedback on it.